Is that on? There we go. There we go. Hello, everybody. Thanks for having us here. This is actually our first time presenting at ZeroNights. We actually came, the three of us, last year to check out the conference, meet the community, and we made it our goal to actually present here next year with some really interesting research, and we hope that you enjoy the presentation. This presentation is leveraging VMware's RPC interface for fun and profit. And today we're going to be talking about specifically the attack surface of VMware and how you would go about writing an exploit and kind of triggering some of the underlying code to break out of the virtual machine. To kind of go over what we're going to be talking about in detail, we're going to introduce ourselves real fast. We're going to go over some of VMware's general architecture and what it kind of looks like, and then we're going to go a little bit more deep into that so that you understand which interfaces that we can actually work with. And then we're going to look specifically at the RPC interface itself and how it works. And then we're going to talk about how you develop tools to actually interface with that with the RPC interface so that you can trigger that underlying code. We'll talk about fuzzing and an architecture around fuzzing the interface itself. And then we'll talk about how you would actually go about exploiting a vulnerability in that code to allow you to break out of the virtual machine. So quick introductions for those of you who don't know who we are. My name is Brian Gorenc. I'm the Director of Vulnerability Research inside of Trend Micro. My primary responsibility is running a program called the Zero-Day Initiative, which is the world's largest vendor-agnostic bug bounty program. Now, what does that mean? That means we work with researchers around the world. We've been doing it for a very, very long time to disclose vulnerabilities to vendors. We work with them by purchasing the vulnerability information off of them. We reverse engineer that information, try to figure out how you would discover an exploit that would attack that vulnerability and provide protection for our customers, along with working with the vendor to get it fixed. I'm also the organizer and adjudicator for the ever-popular Pwn2Own hacking competitions, which we actually did last week or 2 weeks ago in Tokyo. And so we offer big bounties against some of the hardest attack surfaces in the world, including Google Chrome, Microsoft operating system, a bunch of Microsoft products, to be honest, and mobile devices. I also do a lot of research on my own time, working with the guys here behind me to find bugs in Microsoft products. We've done a little bit of research on exploit mitigation patents, and I also do a lot of bug hunting in my own time, focusing mostly on fuzzing and things like that. And that's kind of myself. I'll have Abdul introduce himself.
Hello. Can you hear me? Is it good? All right. So my name is Abdul. I'm a security researcher working for the ZDI. I've been working for the ZDI for the past 4 years. I do a lot of vulnerability research, bug hunting, and exploit development. Before the ZDI, I worked as a pen tester and malware analyst at Morgan Stanley. So I'm also the case lead, basically in ZDI, and ZDI, we accept submissions from researchers. So I'm the guy who's supposed to price these cases and dispatch them to the analysts. So my main role is to keep these cases flowing and price these cases and stuff like that. I've done a lot of research with the ZDI. Notably, I was part of the team that won the Microsoft bounty with the 125,000 for the breaking mitigations. And personally, I was assigned to break the isolated heap back then. I've also wrote the Pwn4Fun back in 2014 exploit for the render exploit. And I've also done a lot of Adobe research. You guys can find me and follow me on Twitter if you want to follow my work. So Jasiel is going to introduce himself.
Okay. All right. Test. All right. I'm Jasiel Spelman. I usually go by Wandering Glitch. I've been with the Zero-Day Initiative team since 2012. I am mostly a reverse engineer, and I got into security mostly because I want to do things with assembly language. And security is a great way of doing that, specifically vulnerability hunting and exploitation. I've analyzed over 1,000 cases, like full root cause analysis, as part of being on the ZDI team. And most of my time is spent trying to find bugs, analyzing cases that are submitted to us, and then also writing code to augment my analysis and exploitation capabilities. I've done a fair amount of work in the Windows kernel and Adobe Flash, and on the team I'm kind of the Apple guy, so anything Mac OS or iOS I end up looking at. Now I'm going to turn it back over to Brian so he can go over general architecture.
All right, so if we look at VMware, it's kind of a really interesting architecture to look at. At the beginning, when several years ago, people thought it was this monolithic beast that, was basically impenetrable. It would take a lot of research to actually go about attacking this, and we're going to try to show you that this is not really the case. If you look at a high level, you can see here, this is kind of what the big bubble architecture looks like. You have guest operating systems running on top of virtualized CPUs that sit on top of some sort of management layer, whether it being Fusion, Workstation, ESXi, things like that. And that communication between the guest and the host operating system is kind of what you're interested in as an attacker for trying to break out of that supposed isolation that exists. Now, you can interact directly with the hypervisor through the virtual CPU, but you can also interact with the hypervisor management layer by interacting with some of the VMware tool libraries that exist, and we'll talk about covering both of those. But that detail there of what exactly is going on there's a lot, right? And so what do you want to actually target as a researcher is what we're going to be looking at. So specifically, what we're looking at between the guest and the hypervisor, the host itself, there is what VMware calls the backdoor channel. Now, why VMware would name something the backdoor is a terrible name for a channel, but that's what they did. It's called the backdoor. It's not like a backdoor like you would think, at least in this community. But it's for communication back and forth between the guests, and there's a lot of commands that exist in that channel. And there's a couple protocols that we want to kind of examine. One is the RPC, or the guest RPC interface, and that's going to be what our target is going to be today. There is quite a few of other communication protocols that exist. There's something called TCLO, which is actually used for host to guest communication, but as an attacker, we're looking for something that goes from guest to host, so we can break out into the underlying host operating system. And the RPC is what we're looking at here. There are two modes of communication with that. There is the low bandwidth mode for transferring small amounts of data, and the high bandwidth mode for transferring large amounts of data back and forth. Specifically, what happens is the VMware hijacks the in and out instruction and uses that for transferring data back and forth between the layers. There are a lot of commands that are available, and it can be used to extract information from the host, and it can also be used to send guest-to-host RPC requests. And Abdul actually, I think, wants to talk quickly about what's possible just from a copy-paste buffer perspective in this interface itself, and what we've done in the past.
Yeah, so through the backdoor channel basically supports multiple functions, and by default it's enabled, so you don't need actually VMware tools to interact with the backdoor channel. So one of the things that we can do as attackers is basically execute functions that grabs or hijacks a clipboard. So if someone copies something from the host OS and then switches back, we can directly copy that even if we don't have VMware tools installed. So the backdoor channel supports a lot of powerful functions that we can leverage for multiple purposes, and one of them is the copy paste, and that's something we spoke about in September at DerbyCon.
Yep.
And you guys can find the slides online with the tools. We actually released a Metasploit module for that, specifically for that, which demonstrates the whole kind of exploitation process of the copy paste issue.
So if we look at, luckily for us, VMware has actually open sourced quite a lot of the functionality in open VMware tools, so we can actually read some of the source code of how to actually interact with this backdoor interface. And we're going to start by looking at backdoor_def.h, which kind of lists all of the different commands. We took a screenshot there just to kind of give you an idea of the different types of commands that are available. And when you talk about RPC, you're looking at the command 1E in hex, and that's what we're going to be targeting today. But there is a bunch of different things: get next piece, get version, a bunch of different things. All of these different commands can be invoked from the guest and trigger code in the underlying host operating system. Now, how do you actually go about invoking these commands? Well, this is a set of assembly that you're going to be using to actually invoke this functionality. Specifically, you're going to be putting a VMX-H into EAX. Then you're going to be putting any command-specific parameters in EBX. And then you're going to be putting the command number in ECX, defining whether you want to use the high or low bandwidth mode in EDX, and then you're going to call the in instruction, and then the underlying code is actually going to start parsing that request. If you want to test out some of this without having to write some of that and just kind of get an understanding of what the RPC interface, again, that's Command 1E, has available to it, VMware actually provides you a tool as part of Open VMware Tools called rpctool.exe, and it will actually take the RPC request, in this case on the screen, vmx.capability.tools_ is upgradable, and it will make that command happen and then return a value up and show you that. So you can kind of get an understanding as Jasiel starts talking about how the tools are actually implemented, you can test this out using the rpctool.exe. If you want to know which RPC commands are available, you can start by reverse engineering VMware-VMX and just dumping the strings, and you can see the different types of RPC commands that are available. In this case, we kind of took a screenshot here of tools.capability, open URL, HDFS server, things like that. There's a bunch of different capabilities that are there that you can actually trigger from the guest operating system, specifically in the guest RPC interface. And if you want to see the handling function for those commands, the code typically looks like this on the screen, and you can kind of start looking at that function to understand how that code is actually handling that RPC request. So kind of to sum it up, there's the backdoor interface that's available that hijacks the in and out instruction. There is several protocols available, but what we're looking at today is the RPCI functionality, and you want to start by looking at Open VMware Tools to get an understanding of how you trigger those interfaces. And what we're going to show you next is different techniques that you can use and different ways that you can actually go about calling those functions and sending malformed data to them. So I'll hand it over to Jasiel, and he'll cover that for you.
Okay, so now I'm going to give some information on the VM RPC interface. And there's this protocol called guest RPC, and it really is a protocol. It sits on top of a couple of different potential channels. We're only going to really talk about the backdoor channel, as Brian was mentioning, but the other possible channels it could sit on would be normal TCP/IP sockets, or also VMCI or vSockets, which is VMware Control Interface. It's basically a custom protocol or custom transport layer that VMware has that is implemented through a kernel driver in the VM side and then extra code in the hypervisor side. For anyone that's ever done any kind of Windows kernel debugging, there is a fantastic modification you can make to VMware Workstation if you had a Windows host called Virtual KD, which would allow for very, very fast kernel debugging, and the way that worked was by hot patching guest RPC on VMware VMX.exe so that you could send the serial messages basically faster. These days it's not required because there's network debugging, but just an interesting aside. So in guest RPC, you have a few messages, and Brian mentioned that's all defined in backdoor-defs.h. There's one in particular, backdoor command message represented by hex 1e. The messages themselves are all defined in guest message def.h, and there are multiple message types. They're all defined within an enum, so you have a message type open, which is going to be represented in assembly or in code by 0. There's message type send size 1, so on and so forth. And we'll see how these get used in the next slide. So here's a few examples of what a simple guest RPC message looks like. You have this message type open, where it's actually being sent as the upper half of the value that's being put in ECX. The lower half is hex 1e, which is saying backdoor command. So if you look at the bottom one, there's message type send size. That was 1 in the enum. So the upper half is 1, the lower half is hex 1e, and then message type close is 6. So upper half is 6, lower half is 1e. And so the way this works is you open a request and say, hey, I'm going to send data. Then you tell it how much data you're going to send. Then you send the data. And then once you've finished, then you close off the connection and say, I'm done.
So I want to add something here that when you open a request with the message type open, you have to put a special value on ABX, which is basically RPCI in hags, and bitwise ORed with a cookie, which is a hard-coded cookie inside, think backdoor defs. And it's basically the value 800000. So if you want to open an RPC session, you have to put that special value in EBX, or else it's not going to go through. And then you can continue with all the other requests.
And then in the other requests, EBX, as you can see, is set to the size of the data. So if you want to understand what those requests look like and how they're actually parsed, you have to look at VMware VMX or VMware VMX.exe, because that's where they're parsed and that's where the code that implements them all exists. You can find it by just doing a string search for guest RPC, looking at the cross-refs for it, and then look for the one that right below it has a pointer to a function. And then if we look at that function, we'll see some function being called with ICPR or RPCI backwards as an argument, and then another argument is a function that's the callback. And that callback is responsible for executing the RPC requests. That exec RPC request function is basically, it gets the request as a whole, and it does validation on the request to make sure that the function being requested to be called is actually valid, so that it has a valid inbounds index. And then it makes sure that you actually have permissions to do so. So Brian and Abdul had mentioned that you have clipboard access. So if you have clipboard request or drag and drop or anything like that, but your VM configuration is set so that that is disallowed, this is where that check occurs to prevent it from going through. If it is allowed, then it'll go ahead and execute it and return any valuable data back to you. So knowing where this function is, it's perfect if you're doing case analysis or exploit dev or fuzzing anything. You can hook this function, and then you can either modify requests in memory, or you can just dump out what's going on and see, if you're testing out an exploit, you can see exactly what your exploit is sending through the interface. For this, we've used PyKD, which is just a Python wrapper around debug engine, and it works out fairly well. We just set a breakpoint on the function. We have the offset thanks to reversing it. And at that point, we just need to look at R8, which is going to have a pointer to the buffer, and then we read R9 worth of bytes, because R9 is going to have the length. So I'm going to show a quick video of doing exactly that. It's going to be kind of hard to see, sorry. You'll see a hex dump though, and that's it sniffing and dropping out one request that's been made. So it's injected. Go ahead.
So it's simply just attaching to the VMware VMX and setting a breakpoint on that function at specific offset, and then just dumping R8 and R8 based on R9, which is the length. That's it.
Okay, so now we have a way to dump out what's being sent and what the hypervisor itself is receiving. Now we need a way of actually being able to send commands to it from the guest itself. And this is important for a few reasons. As we've mentioned, we buy vulnerabilities and we have to look at other people's vulnerabilities, but then also for exploit development, for fuzzing, we need to be able to control what gets sent to the hypervisor. And we need custom ways of doing that, because obviously the legitimate ways are not going to do things we want. There is OpenVM Tools, the code base that is maintained and released by VMware that Brian had mentioned. But there are some issues with it in that there's also vmtools.dll, which implements a few functions differently, or in some cases only is implemented in vmtools. Additionally, if we're writing an exploit, having any external dependencies is always bad. It makes things less predictable. There's version issues, all sorts of things. And if we can remove that as a dependency, it just makes it better. So the first thing we attempted was basically just using OpenVM Tools, adding it to the include directories, and then just calling load library on vmtools.dll, and then repeatedly calling get proc address on the various functions we need, which kind of works, but as I mentioned, there's some functions in VM Tools that are implemented that aren't available through OpenVM Tools. In order to get those, we end up having to use raw assembly, which does work, but it's just kind of an extra pain, and if we're having to implement raw assembly, why not do something else entirely? There's also, if we want to send any custom RPC requests, then we're going to have that in hard-coded assembly. It's very doable, and the three snapshots of guest RPC code that I sent earlier are basically mirrored here, slightly differently with some hard-coded values, but effectively the same. And so that does work, but it's just not ideal. We are very much a Python shop, and anything we can do that's going to be accessible through Python is beneficial to us. We have fuzzing frameworks in Python, and we like to do things in Python. We also want to be able to query the interface from Python naturally, And so we have two methods of doing that. One is a C extension, and then one is pure Python using C types, which is a foreign function interface for Python. We also, Abdul had mentioned that we had a presentation at DerbyCon a couple months ago. Our DevOps manager, Colonel Smith, used to be a contributor to the Metasploit project, and he really wanted a interface for VMware in Ruby. And so he implemented exactly that on top of Metasploit, and we released that, I think, a couple weeks ago, a month ago.
It's end of September.
Yeah. So the C extension way, it's fairly straightforward. It's basically just a shared library, a PYD on Windows. I think it's a .so on macOS or Linux. And it works fairly just like a normal Python library in that you can import it and then call functions, and it just treats it as if it's pure Python. The way that works is you have an array of the methods that are defined that have various names, which is how you'll access them, as well as a pointer to the function that implements it. Then you have an initialization routine that calls PyInit module with the name of the module itself, as well as a pointer to the array of methods. And when you call import, it's got to match whatever you've sent when you call PyInit module. On the right side, you can see what one of these functions looks like. It's fairly straightforward. We're just calling pyarg parse tuple. And so it'll expect some sort of buffer object, and it'll return back a pointer to the buffer as well as the size of the buffer, at which point we're just calling our custom RPC send function with those arguments. We're returning nothing because this is all going to run on the client side. We don't care what it gets back, because any side effects of running a custom RPC function, we're going to see in the hypervisor either through a crash or through having exec RPC request hooked. Looking at the C types way, this is the way I prefer. I like pure Python. It makes it a little bit more portable, and it's just a little easier to me. We have a buffer of raw assembly. In our case, we're using hard-coded values, but we could just as easily use a project like Capstone to dynamically do this. It's just that for this particular case, what we're fuzzing, what we're sending from the guest is all controlled by the request itself and not by the instructions itself. So we just need the instructions to trigger the code we want, and then we'll pass messages that are mutated or whatever. At that point, we tell Python that there is a function, and that's the C type, cfunc type. And we're telling it that it returns a D word, and it takes a pointer, and it takes another D word, so the pointer to the buffer and the size. And then we're calling virtual protect to mark that memory as executable. On OS X or Linux, that's just a call to mprotect, doing the exact same thing. At that point, we then instantiate the function itself by saying, here's the bag of bytes that we want, and this is the address for it. And just for convenience, we create a wrapper around it to break out the buffer into the pointer to the buffer and then the length, just because that's a little bit easier to do for various buffer types through Python than through assembly. Ends up being a little bit slower, but it's still much better, and we can call all this natively from Python. So I'm going to show a quick video of the C extension method. The C types method is effectively the exact same, but all that's going to happen is showing that there's no RPC send.pyd. So building it real quickly, and then showing that it now exists. And then we'll call Python, import it, and then we'll trigger disk.shrink, which is a method that you can call from the VM to shrink the outer disk. And you'll see that because the VM itself now shows shrinking disk. And with that, I'm going to hand it over to Abdul to talk about fuzzing the RPC interface.
All right, so fuzzing. So this is something that, since we have tooling now, and we have like a nice Python module and whatnot, so we can actually start developing a decent fuzzer and plug it to our framework. So this section, I'm going to talk about two fuzzing methods, basically ones that I've used. I'm going to talk about the pros and cons of them, some of the things that I actually ran through and whatnot. So this is not a complete guide of how to fuzz the RPC interface, but just some methods that can get you guys started with the fuzzing procedure. So first, we should understand that writing a fuzzer for the RPC interface in VMware is not an easy task. It requires a lot of tooling. And by a lot of tooling, I mean you need to figure out which code has to run on the guest, which code has to run on the host, and all that kind of stuff. There's also some problems that we should tackle. Part of it is like monitoring, test case generation, and all that kind of stuff. Like how we would actually manage all the VMs, which is something we can do easily with built-in tools in VMware. So basically, this is how I started with the whole architecture. I have my framework running on the host. I have like VMware VMX spinned, which is VMware workstation. So basically, my framework spins an agent which has a mutator that feeds the agent. The agent attaches to VMware VMX, and you're going to have some test cases being sent to the guest OS. As of like managing VMs, so if you have like 10 VMs and you want to fuzz all that, you can basically manage them through VMrun, which is a tool that's shipped with the VMware workstation. So this works. I'm not going to say it's ideal, but it has some issues. There's a lot of code involved in the host, on the host, and on the guest. But once you have that framework kind of developed, then things would be easier, and you can plug through framework, which requires a little bit of tooling. So this was the first approach that I took. It's just classical, but it kind of works. All right, so the next approach that I took was, since we know exactly where the RPC functions are being parsed and are being handled, just like Jasiel mentioned the execute RPC function. So why not hook that function and do some in-memory fuzzing? And by that I mean we have the PyKD script that he talked about, which dumps that RPC request, right? And in a nice format. So why not modify that script and basically just grab that request, modify it in memory, and then just ship it, right? And it works really, really easily and smoothly. So all we have to do now is just, instead of just hooking and dumping, we just hook, grab that request, modify it, and then ship it, and then just wait for crashes. We still have to take some things into consideration, like as of the monitoring the crashes. Since we're doing everything in PyKD, that's relatively easy. So all we have to do now is just write an additional code in PyKD that would just attach, we're already attaching to VMware VMX, but just monitor for these crashes. It's easy, and it works really well. So in a nutshell, this is how it's going to work. Basically, you have your PyKD script. It's going to attach and monitor VMware VMX, hook, and then start fuzzing. Basically, just wait for these RPC requests and then start modifying them. You can get a little bit more advanced. Since we know exactly where the function lies inside VMware VMX, we can plug WinAFL to it and then have it fuzzing. So this is basically how we kind of approached it, and it worked really well for us. All right, so the final section that I'm going to be talking about is exploitation, and specifically user after fee exploitation in VMware. So I'm going to be talking about a bug that we received back in March, right before Pwn2Own. And it was quite interesting because usually before Pwn2Own, like a week or 2 weeks before that, we start getting a spike in submissions. And when we got the submission, we directly realized that it's kind of a defensive submission. So by defensive submission, I mean sometimes the contestants would send specific bugs to us so that they would duplicate other contestants during the contest. And if that was the case, then we would flag that attempt as a partial win. It's not a full win in Pwn2Own. So that's why contestants start sending us like submissions, defensive submissions, as we call them. We also had an interesting case, I think, last year of a Chrome bug. Remember that one?
Yeah, it was submitted. So we had Pwn2Own on, let's say, Wednesday, and 3 days before the contest, it was submitted to the vendor and ended up duping one of the teams. Yeah. And it turned out that it was another competing team that had released it specifically to, to negatively impact them during the contest. Yeah,
so that was a defensive submission. All right, so let's talk about the bug itself. It's relatively simple. So it's a drag and drop functionality in RPC. Basically, you have to set, in order to trigger that bug, you have to set the version and then retrieve that version, set it again, retrieve it again, then you're going to force the free. After that, you can call whatever drag and drop function, and you're going to be able to trigger the reuse. And It's relatively simple. You can execute all that in RPC tool.exe. You don't have to do any special tooling. You can just attempt to trigger it through RPC tool from the command line, and it works really well. All right, so I personally come from a browser exploitation background, so this was all relatively new to me. I didn't know actually how to analyze it or how to exploit it. So I started applying my knowledge in browser exploitation to the same actual thing. So initially, when you trigger the crash, you're gonna have something like this, which is basically dereferencing an object from in RCX. And the first thing that I do is run bang heap -p-a, and then it gives me a nice stack, and basically just show me that object has been freed. So that proves that it's a use after free. That's the initial thing that I did. So next, again, when you're doing browser exploitation, use after free browser exploitation, you have to find exactly the size of that object, right? And in order to do that, I applied my browser exploitation knowledge to the same scenario, which is breaking right before the free happens, and then run bang heap -p-a, and then you're going to get the size. In this case, it was B8, so that's exactly what I needed. So now, since we know exactly when it got freed and the size of the object, next we should determine how to override that freed object. Again, it's applying my browser exploitation knowledge here. Okay, so let's step back a little bit and talk about, so usually when you're doing use after free exploitation in browsers, you have JavaScript. You have the luxury of JavaScript, which allows you to kind of reclaim these freed object easily. But we don't have that luxury here. We only have RPC functions, right? So we have to play by the rules, which is play around with the RPC functions. So I started doing some reversing on the various RPC functions that I can hit. Some of them, as Brian mentioned, are privileged, so we cannot actually trigger these RPC functions, and some of them we can actually hit. So one of these RPC functions was the guest temp directory, which takes a string as an argument. So all I had to do is send that function with an arbitrary argument, like a bunch of A's, since it's a string argument, and then with that specific size, V8, and then it was a win. So basically, I was able to override that object with 414141. So for the record, in order to exploit this vulnerability, we need a leak, because basically we have a straight path to RCE, so we need some kind of a leak. So in order to exploit this one, I used a memory leak from Tencent. Basically, they used that in Pwn2Own, and it was calling a specific backdoor function in a high band mode. And what had happened when you call that function, it returns a bunch of memory, because it's an uninitialized memory problem, and then we were able to leak VMware VMX base. So that's exactly what we needed. So now, since we have all the ingredients, we have to start thinking of where to actually put our payload or wrap chain in. So again, we don't have the luxury of JavaScript, so we don't have typed arrays, we don't have all that kind of stuff. So I started reversing again these RPC functions, and I found this nice one, which is Unity window content start. And in this function, it grabs the argument and it sets it in a global variable, which is awesome. So basically, if we have the base of VMware VMX, then we know exactly where our payload is, since it's being set in a global variable in VMware VMX. So that problem is solved, right? So we know exactly where to put our wrap chain. We know where the offset, where that wrap chain is specifically set, like in VMware VMX as a global variable. All right, so how does it actually look like? So basically what we have to do is first send a Unity request so that our first wrap chain is stored in a global variable. Then we should trigger the free, right? Then we should override that object with our arbitrary object, and then trigger their use. So basically how it's going to look like, you're going to set your payload in the global variable, which basically points to a single wrap chain which exchanges RDI with RSP, and then trigger the reuse, and basically have it execute the wrap chain. And for the record, I think up to version 12.5.7, I did not check the recent one. You have a region in VMware VMX that's RWX. So your wrap chain should be relatively simple. Basically, just do a mem copy your payload, put it in that specific region, and then return to it since it's RWX, and then our problem will be solved. So I'm going to show you a quick demo of how this exploit works. It's relatively simple and fast. So we wrote it in Python using one of our modules. And we have a leak. And basically, we've got popcalc. So for the record, VMware VMX on Windows runs in medium integrity. It doesn't run in a lower integrity. So if you pop VMware VMX, you can have a medium integrity code execution. There's also some services in VMware, specifically VMware NAT, and I think there's another one. Is there?
I think the DHCP server also.
Yeah, these run in system. So if you pop one of these services, basically you can get system on host rather than medium integrity. So
and because all of the processes run as medium integrity, if you manage to break out of one of the VMs, that means you can then inject code into any of the other VMs.
Yep.
So that's easy to move laterally at that point.
Yep. And with that, I'm going to give it to Brian so he can conclude the talk.
So yeah, one of the reasons that we're talking about this is, we've been trying to encourage researchers to kind of look at some isolation. Everybody, probably in this room has used VMware for either malware analysis or running some malicious code in there. And the thought is that this isolation is enough to keep you from being compromised on your host. And I've talked to some people who've worked in the government space, at least outside of Russia, that are thinking of using this virtual technology to actually separate different classification regions, right? So top secret or whatever it is in that given country. And just when you look at the attack surface that it's available, it's not exactly the best idea, right? Still, that physical isolation is the best for some of these really sensitive areas. But as we looked at what we do with our contest and what we do with our program, the Zero Day Initiative, is we try to put money where we think researchers need to go look to help us harden some of the attack surface and bring out research that is actually going to cause some impact on the underlying ecosystem that we all live in. And back 2 years ago, we decided that we would put $100,000 bounty on VMware exploitation and exploits that are coming out of that can break out of the virtual machine, at least in Workstation. And the first year that we did this at the Pwn2Own contest, we really didn't get any entries, which is what we've experienced now. I've been running. This is my 10th Pwn2Own to run a couple weeks ago. Is that it takes researchers, when we put a $100,000 bounty on something, it takes them a year to actually put it together. And so we were actually looking forward to the contest in March because we thought for sure that we would actually get some exploits in VMware. And so we also put bounties on Hyper-V. So next year, all of you Hyper-V researchers out there, come on out and win some money. But we saw lots of different exploits. Specifically today, we're talking about RPC and guest RPC communication. But we did see Jasiel and Abdul here go over some of the other VMware exploits that we received at the contest itself. So if you guys want to cover that, it kind of shows you just all of the different attack surface that's available in VMware.
We definitely got other bugs, and one thing that's very telling to me about VMware in particular is that they had patched, I think, the week before Pwn2Own, so we had to update everything, which is fine, typical for vendors. But as part of the Pwn2Own disclosure process, we give the vendor, we make sure that we have not seen the vulnerability, because then we count it as a partial win. But then we hand it to the vendor and make sure that they have not seen the vulnerability. And I remember I didn't pick it up on the first one, but on the second one, I still had a USB in my hand, and I handed it to the VMware guy, and I asked him if he knows whether or not this is a duplicate. I told him it looks to be different to me. This is a heap-based buffer overflow versus the previous one, which was a stack-based buffer overflow. And while I put it in his hand, he's holding it in his hand and looks at me and says, "It's unique." And I'm just looking at him very confused, and he explains that every security bug that they knew about had been patched the week prior. And because I was telling him that this bug was unique to the other one, it was unique to them. And the fact that a massive product like VMware only had two unknown vulnerabilities is massively terrifying, because so many people depend on it for security when they really shouldn't. It was very, very telling for us to see that happen.
Okay, so if you guys want to cover, because we had a couple really interesting exploits that came through. So
We talked about the RPC attack surface. During pwn-to-own, we got vulnerabilities in SVGA and in XHCI. And ever since the contest, we started getting a spike in submissions, specifically in SVGA. But in order to hit that code, you need to escalate inside the guest. So basically, you need to execute from system inside the guest host in order to load a driver and exploit SVGA. I think the bug that we got in SVGA was an uninitialized stack pointer, stack variable, and it was really, really amazing how they exploited that. It was exploited by Tencent. And as I mentioned, they used a memory leak in the high band, in a backdoor functionality, specifically in the high band mode. And it was an uninitialized variable as well. Basically, it was just dumping back memory, and that's how they were able to leak VMware VMX. You want to talk about the XHCI one?
That one was a buffer overflow. The most interesting thing about it was that you did not have to be privileged in order to hit it. I believe they were for extra points.
Yes.
I can't remember.
Yes.
But the interesting thing to me is that basically VMware seems to only test the happy path, the path that you will typically take, rather than test for any sort of error conditions. And so if you just don't go the normal method when you're calling functions, then it breaks all of their assumptions, and they seem to have vulnerabilities there. It's just kind of interesting. At that point, exploitation, as Abdul was mentioning, is fairly trivial, thanks to the read-write executable memory region within VMware VMX. And at that point, it really is game over. So, yeah.
Yeah, it's a really interesting attack surface, and we talked about the complicated fuzzing infrastructure that may be necessary. I mean, one of the contestants actually was just using RPC tool, which we talked about at the beginning, was calling this in different configurations to try to trigger an underlying use after free that ended up being pretty deadly in the contest. So that attack surface, not only in RPC but also SVGA and the different attack surfaces that are there are a lot of bugs there, and we encourage you to go look for these vulnerabilities and submit them to programs that are going to actually responsibly disclose the vulnerabilities, or to contests like pwn-to-own or bounty programs that exist out there that will help us actually, kind of secure that attack surface itself. And with that, we're the Zero Day Initiative program. We buy bugs. If you do submit to our program and you're located here, obviously come and introduce yourself and say hi. And you can talk to Abdul and try to get the price up a little bit if you want. But it's been nice to come out here and present. It's been we came out here like I said at the beginning of last ZeroNights over at the Cosmos, and we definitely wanted to participate in this community. And we're glad that you had us here. And thanks for coming out for our talk. If you have questions, we're actually going to be up in in the hallway there between track 2. Come up and ask any detailed questions that you have about the contest or about the exploits or the attack surface that we just covered.
Thank you.
Thank you.
Sure. So the question was, the question that we got asked up here was about whether ESXi and that type of attack surface is safe. If you want to cover that one, Jasiel.
So it seems to be unexplored, similar to how VMware Workstation and Fusion are, but at least 2, maybe 3 of the bugs from pwn-to-own that affected Workstation also affected ESXi, and I don't remember what particular version. I want to say 6.0 and 6.5, but I'm not entirely sure about that. So that cookie isn't quite authorization. It's effectively just a flag that is used to discern what type of message is coming in. It's basically to prevent any sort of corrupted messages to go through. Yes, so So the question is the first cookie that we had mentioned, the hex
80000.
Yeah,
That is specifically just to make sure that the message type open is a valid request.
It is not a cookie.
It's not actually a
I
cookie.
see.
The code calls it a cookie, but it's really just a flag to say we want to invoke.
Not any authorization of who is calling really.
There's no authorization whatsoever. The closest to any authorization for any requests are specifically for, say, the SVGA stuff or requests of that nature, where it ensures that you're operating from ring 0, but that isn't enough of a limitation, and it doesn't actually validate that the request itself is legitimate.
Okay. Okay. Thank you.
Yeah. Yep. Thank you.
Yes. Is there some options to protect EXXI host or to not execute this RPC request?
Sorry.
How to protect against this?
Unfortunately, the only real way to protect, the question is how do you protect against this?
Rebuild
The only
some
real way to
modules or-
protect is to find any bugs and then get VMware to fix them. There unfortunately isn't a real good way to do that. If you wanted to be brave, you could hot patch VMware VMX to massively reduce functionality, but you're not really going to have any other option just because it's too involved. Huh? You could also just use something else. That is also an option. But with VMware, the options are limited to reduce the attack surface. ESXi does have a slightly reduced attack surface in that they don't support, say, drag and drop because there is no drag and drop like UI. But they also have other attack surface, and it all just varies. Yeah. Thank you.